Hey guys, I'm gonna go over the part of the 3.6 video where we go over the practice problems. So there is a video in Canvas where someone else who made these notes will go over the first part of this right here. I'm gonna go, excuse me, I'm gonna go over all the practice problems. I'm probably gonna do them really quick because I am really burnt out of making videos. I've been making a lot of them, and yeah, I'm gonna do them really quickly because I'm done. So, let's go for it. So hopefully you have an understanding of finding second derivatives. This is just regular second derivatives, and then this right here is implicit differentiation. So finding second derivative with implicits. So let's go here. So we're trying to find the second derivative. So I'll start with the first derivative. Derivative of sine is cosine of x. And then plus the derivative of 1 over 5x. The derivative of the natural log of 5x, which is 1 over 5x, times by 5 for the derivative of the inside. So this right here is just going to simplify to be 1 over x. So plus 1 over x. And now for the second derivative, we'll take the derivative of what we have here. So the derivative of cosine is negative sine of x. Now, since 1 over x is equivalent to x, this right here is equivalent to x to the negative 1. When I take the derivative of that, that's going to be negative x to the negative 2. You can leave your answer like that, or just write it as negative sine of x minus 1 over x squared. All right, for 2, so for the first derivative, this is going to require the product rule. So we'll do the first times the derivative of x, which is 1, plus the derivative of e to the x, which is e to the x, times by the second. Okay, for y double prime, so we'll take the derivative of this term, which is going to be e to the x. Then the derivative of this term, well, the funny thing about this term right here is that this term is the same thing as our first derivative. So when I took the derivative of e to the x times by x, we got all of this right here. So when I take the derivative of this, which I'm taking it right here, again, I'm just going to get all of this in return. In short, we're just going to use the product rule, and whenever I do that, I get plus e to the x times by x. I get the same exact thing. When I take the derivative of this, I get this. I know that because I already took the derivative of this, and I got this right here. So it's just a repeat. And then if you want to combine like terms, that's 2 e to the x plus e to the x times by x. I'm going to rewrite this. When I have trigs and powers, I usually like to rewrite it. So for the first derivative, that's going to be 2 times by sine of x times by cosine of x. So derivative of the outside, keep the inside the same, and then for the chain rule, times by cosine of x. So that means for the second derivative, it's going to require the product rule. So I'll do the first times the derivative of cosine, which is sine, plus the derivative of the first, which would be, 1 second, did I do that right? So did the first times, it's going to be negative sine, there we go. So I'll just put the negative right here. The derivative of sine would be negative cosine. I'll put the negative right there. And then plus the derivative of 2 sine of x, which would be 2 cosine of x, times by cosine of x. So in short, we have negative 2 sine squared of x plus 2 cosine squared of x. And that's good right there. For 5, now this is implicit differentiation, but for 5, so we're trying to find the second derivative, but this is the first derivative, so we already have it. So I just need to take the derivative once. So y double prime is going to be equal to 2y y prime. Don't forget that this is implicit, so we need the y prime, plus 2. And if they covered it in the video here, hopefully they did, but derivatives should not be defined with other derivatives. It should be, or we should, if we can, y prime or our derivatives should be defined in terms of x and y. So we are going to substitute this y prime right here. Since we already know what y prime is equal to this right here. I'm going to substitute this in for y prime. So that's going to be equal to 2y, y squared plus 2x minus 1 plus 2. If you want to distribute that in, you definitely can, but I'm going to leave it right there. That's our second derivative. All right, for 6, so I already have the first derivative. For the second derivative, now the derivative of 1 over y is going to be the same for the derivative of 1 over x. So hopefully you have this memorized. I told you guys that, well, we actually already did it up here. The derivative for 1 over x, the derivative for 1 over x is negative 1 over x squared. I did tell you guys to memorize that. So that's going to be equal, so the derivative of this is negative 1 over x squared. So for 1 over y, the derivative for that, it's going to be negative 1 over y squared times by y prime for the chain rule or implicit differentiation. So my first term here, when I take the derivative, is negative y prime over y squared minus 3 for the derivative of negative 3x. And then I just have to replace this y prime with the function. So y double prime is going to be equal to negative 1 over y minus 3x over y squared minus 3, and I do not want to simplify, so I'm not. For 7, we'll have to use the product rule. So for y double prime, that's going to be equal to the first times the derivative of y squared, which is going to be 2y y prime, plus the derivative of x, which is 1, times by y squared. So just cleaning it up a little bit, that's going to be 2xy y prime plus y squared. And then the y prime, I'm going to substitute with what we have there. So that's going to be equal to 2xy times by xy squared plus y squared. And then even cleaning this up right here, that's going to be equal to 2x squared y to the third plus y squared. And there you go. For 8, the derivative, this is all implicit right here. This is all, and I don't even have a first derivative here. So that means for 8, 9, and 10, you're going to have to find two derivatives. For these ones, we already had the first derivative. So for first derivative that we're taking here, cosine of x plus y. Now for the chain rule, we'll have to multiply by the derivative of the inside. So that's going to be 1 plus y prime equal to 2. And then let's solve for y. So I'm going to divide by this part right here. So we'll have 1 plus y prime equal to 2 over cosine of x plus y. And then I'll subtract the 1. So I'm going to subtract that 1 right there. So I'll get minus 1. Notice I'm going to put this over here because I do have to take the derivative again. And I don't want to use the quotient rule here. So I'm going to rewrite this where I'm going to bring this part up with the cosine, but then I'm going to make this to the negative 1. And there we go, just some algebra right there. And then I already brought this 1 over here, so that's going to be gone. Okay. So if you're confused, I just did algebra right there. That's what I did. Okay. And now we'll take the second derivative of this right here. So y double prime. So we'll have to use the chain rule. We'll bring down the negative 1. So it's going to be negative 2. We'll have cosine of x plus y. That's going to be to the negative 2. Now I'm going to have to multiply by the derivative of the inside. So I'm going to have to multiply by negative sine of x plus y. Then I'm going to have to multiply by the inside of that. I'm going to have to multiply by 1 plus y prime. So very nasty derivative. And then I would have to substitute all of this right here for y prime. I think you guys get the idea. I'm going to, what is that right there? Did I forget? Oh. There we go. So yeah, that's what you do. Substitute that right there. It's a messy derivative, messier second derivative. So I'm just going to leave it like that. All right, for 9, so we'll do the derivative of e to the x, which is e to the x equal to 3y squared times by y prime, and then the derivative of 1 is going to be 0. So solve for y prime will be equal to e to the x over 3y squared. Now I'll take the derivative of this, so the second derivative, we'll have to use the quotient rule. So we're going to do low d high minus high d low, that's going to be 6y prime, all over 3y squared. And then this y prime has to be substituted here. So this is going to go for y prime. So then y double prime is going to be equal to 3y squared e to the x minus e to the x times by 6y times by e to the x over 3y squared all over 9y to the 4th. I don't even know why I did that, because I don't want to. Okay, but that's how what it would look like whenever you replace y prime. All right, for 10. So derivative of the natural log of y is 1 over y times by y prime. So I'm just going to write that as y prime over y equal to 5. That means that y prime, when I solve for it, is going to be equal to 5y. So when I take the second derivative, the derivative of 5y is 5, and then I have to multiply by y prime. Then I'll make my substitution. So I'll get y double prime is equal to 5 times by 5y, which is going to be equal to 25y. All right, I told you I'd be going fast. For 11, evaluate for the second derivative at the given point. So the first derivative is going to be equal to negative 9x squared minus 8x to the negative 3. The second derivative is going to be equal to negative 18x plus 24x to the negative 4. And then I'm going to plug in negative 2. So that's going to be equal to 36 plus 24, negative 2 to the negative 4. Doing some algebra, that's going to be 24 over negative 2 to the 4th, which is going to be equal to 36 plus 24 over 16 right there. For 12, so first derivative, we'll have to use the product rule. So that's going to be the first times by the derivative of the second plus the derivative of the first, which is 1, times by the second. So that is going to be equal to 1 plus the natural log of x. So second derivative, the derivative of 1 is 0, and then the derivative of the natural log of x is 1 over x. So f double prime of 1 is going to be equal to 1. All right, for 13. Oh, man. Okay, yeah, let's do it. So, I really don't like how these are written. I would much rather do these derivatives with powers. So I'm going to rewrite this. This is 3x to the negative 1/2, and then minus 32x, not negative 1/2, it would just be positive 1/2. And then minus 32x to the negative 1. So my first derivative is going to be equal to 3 over 2 x to the negative 1/2. And then it's going to be plus 32 x to the negative 2. Second derivative is going to be equal to negative 3 over 4 x to the negative 3/2. And then minus 64 x to the negative 3. So f double prime of 4 is going to be equal to negative 3 over 4. I'm going to put this in the denominator with the 4. That way I make my exponent positive. Then it's going to be x to the, it's going to be 4. And then we're going to have 4 to the 3/2 minus 64 over 4 to the 3rd. And I'll be honest, I'm not gonna. You definitely probably should simplify that, but I think I'm good. So for 14, we already have the first derivative. We need the second derivative, and we're gonna plug in this point right here. So this is a good question, though. I can see this being a question on the test, something like this right here. So we'll find the second derivative. So y double prime is going to be equal to negative 3 sine of y but then we have to multiply by y prime. So we have the 3 here, the derivative of cosine is negative sine, then we'll have y, but then we'll need to multiply by y prime, and then plus 5. Now we're going to plug things in. So to plug things in, here's how we'll do it. So we're going to y double prime 2 comma, I'll just write it like this right here, is going to be equal to negative 3 times by sine of y, which is pi over 2, times by y prime. Now for y prime, what am I going to plug in for y prime? Well, this is y prime right here. So I'm going to plug in this point right here for y prime, and that's what I'll plug in for the value of y prime. So I'll say y prime of 2 comma pi over 2. That's going to be equal to 3 cosine of pi over 2 plus 5 times by 2. So that's going to be equal to 3 cosine of pi over 2 is 0. Right? I feel like I'm doing something wrong here, but I'm really not caring too much right now. Cosine of pi over 2, isn't that... Yeah, no, that's 0. 3 times by cosine of pi over 2 times by, and then plus 10. So this is going to be equal to 10. Sure, times by 10. And then plus 5. So I think I got it all. So this is going to be equal to negative 3 times by 10 plus 5. So it's going to be equal to negative 30 plus 5. It's going to be equal to negative 25. I really feel like I did something wrong here because I don't remember getting that in class. But if you guys spotted what I did wrong, then good for you. For 15, so we need to find the second derivative. So I'll take the derivative of this right here, which is going to require the chain rule. Not the chain rule, the quotient rule. So we'll do low d high minus high d low, which would be 2y prime, and then 2y minus 3 squared. So we'll plug in our values. So we're going to plug in 2 right here. We'll get 4 minus 3. We're going to get 1 times by negative 1 minus. So we're going to plug in negative 1 right here. So it's going to be 5 altogether. Times by 2 times by y prime. So y prime is going to be equal to, we have to plug this in for y. So if we plug in, that's going to be 5 over, and then we plug in 2, so that's going to be 4, so it's going to be 5 over 1, that's just going to be 5. And then all over, I'm going to plug in 2, 4 minus 3, which is 1. This is just going to be 1. So we'll get y double prime is equal to negative 1 minus 5 times 5 is 25. 25 times 2 is going to be 50. So this is going to be equal to negative 51. Okay, and then lastly here, so we'll do the product rule because we have those two right there. So y double prime is going to be equal to the first times the derivative of e to the y. Don't forget to take do the y prime, and then plus the derivative of the natural log of x, which is 1 over x, times by e to the y. So y double prime is going to be equal to, we'll plug in e for x, so this is going to be the natural log of e, and then times by e to the first. Then for y prime, so y prime is going to be equal to the natural log of e times by e to the first. Now natural log of e is 1, so 1 times by e to the first, so that's just going to be e. So then times by e plus 1 over e times by e to the first. So that's going to be e squared because that's 1, that's e times e, and then this is just going to be 1. 1 over e times by e is going to be 1. So plus 1, I think, is what our answer is going to be. Okay, and then we have all this right here. I don't know what this is. So, okay, this is just find derivatives of the following. So f prime. So f prime is going to be equal to 21x to the 6 minus 12x squared plus 5. Second derivative is going to be whatever 21. Anyways, I think you guys can keep going. If I write this as 4x to the positive 1/2, the first derivative is going to be 2x to the negative 1/2, and the next derivative is going to be negative 1x to the negative 3/2. So negative 1 over x to the positive 3/2, I think. And then, yeah, I would write this as x to the negative 3 minus 1/2 x to the 4th. So the first derivative is going to be negative 3 x to the negative 4 plus 2x to the 3rd. Then it's going to be 12x to the negative 5 plus 6x squared. And then the next derivative is going to be, is that negative 60x to the negative 6 plus 12x, I think. Okay. All right, so we have all these functions given here. Find the following. So f double prime of 2, so you'll take the derivative of that twice. You'll plug in 2. You'll take, for g triple prime, you'll take the derivative of that 3 times, plug in negative 3. But I hope that we get the idea at this point right here. If you feel like you got enough practice, then that's great. This is a lot of good practice. It's a lot. It's repetitive, I think. But that's good for math. We like repetitive because once it gets repetitive, then that's kind of the indicator that we're getting it, that we know what we're doing. So, yeah, hopefully that's enough practice for you guys, and that's going to be it for that.